So in this video, we're going to explore the concept of the critical state, okay, the critical parameters, and some parameters that can be derived from the values of those critical parameters. Okay, so nakikita nyo ngayon, meron tayong phase diagram, meron tayong mga boundaries na tinatawag. So this is the solid boundary. If you are at a pressure and temperature that is located in this boundary, most probably ikaw ay solid. So kapag nandito naman, you are liquid, and here, if you're gas. So, isa lang ang phase na present at isa lang ang phase na makikita nyo doon sa system. So, at the boundaries, for example, at the solid-liquid boundary, at 1 atm, kapag ka nandito ko sa point or nasa boundary ka ng solid-liquid region, your temperature is called the normal melting temperature. Pagka nandito naman sa point na to, that is called the normal boiling temperature. If you are at the region where the three phases coexist, solid, liquid, gas, dito nag-intersect yung tatlong boundaries, you are at the triple point of the system. So, the triple point temperature and pressure is unique, okay, kapag unique siya for every compound or element. Okay? Unique siya sa isang substance. Okay? Dito naman, sa point na to, this is called the critical region. So, sa critical region, nawawala na yung liquid-gas phase boundary. So, this is also called the critical state kasi yung liquid na or yung substance na form nyo ay hindi na siya liquid or hindi na rin siya gas. Although may properties siya both na liquid and gas. So, at the critical region, nawawala yung phase boundary. So, hindi na kailangan ng energy para mag-cross from one boundary to another. Hindi na dito or nawawala na yung mga properties like latent heat, okay, yung mga enthalpy of vaporization, condensation. Hindi na rin dito applicable yung processes ng condensation and evaporation kasi wala na silang latent heat. Kumbaga, yung mga properties ng liquid and gas, nagsasama na siya at the critical region. So, beyond the critical region, okay, or beyond this critical point, okay, critical point, ang tawag sa fluid ay supercritical fluid. Okay? So, kapag ka supercritical fluid ka, yung parameters mo ay beyond dun sa critical region. Okay? So, for real gases, to be able to determine the critical point or the critical isotherm, you'll have to find the isotherm, okay, where the inflection point, okay, partial derivative of pressure with respect to volume, and the second partial derivative of pressure with respect to volume are both zero. Ibig sabihin, yung slope ng isotherm na yon, okay, tsaka yung rate of change ng slope ng isotherm na yon ay both zero. Hindi kasi yun nangyayari kapag ka subcritical. For example, this particular line here, this is subcritical. Okay? Meron siyang dalawang inflection points. So, kapag dalawa yung nahanap yung inflection points, it's not very indicative of the critical isotherm. Kasi kapag dalawa yung iyong points, your second partial derivative is most likely not zero. Okay? And also, since nandito na tayo sa topic ng mga subcritical temperatures, makikita nyo na meron tayong tinatawag na van der Waals loop. So, this van der Waals loop is a loop that exists in real gases, especially yung mga cubic equations of state. Okay? Tapos, nag-violate siya ng Boyle's law. So, according to Boyle's law, as the pressure increases, the volume should decrease and vice versa. Pero dito sa van der Waals loop, nakikita nyo na as the pressure increases, the volume also increases, which doesn't make sense and it doesn't happen in real life. So, James Clerk Maxwell found a way to resolve this issue on the van der Waals loop. So, ang ginawa niya, kinuha niya yung line, okay, or yung pressure where the areas here and the areas here, or the area here and the area there are equal. So, kapag equal yung area na to, tsaka area na to, you can just subtract them, okay, resulting in a line which has a zero slope. So, this is the zero slope line. Okay? So, this is called Maxwell equal area correction. So, it's used to, quote-unquote, correct the relationship between the pressure and the volume. So, indicative siya ng phase change because if you can, as you can see here, nag-i-increase yung volume at constant pressure. Okay? So, an indicative increase in the or the molar volume at constant pressure indicates change in the phase. Okay? Pwedeng gas to liquid or liquid to gas. Okay? So, the curve that is formed by the points, okay, that are intersections of this particular line, okay, sa iba't ibang isotherm, okay. So kapag nag-drawing ka ng maraming isotherm, magfo-form ka ng mga points of intersection, tapos pwede mong i-connect yung mga points na yon to this curve. Okay? So this curve is sometimes called the liquefaction curve kasi at this curve, makikita mo yung intersections ng molar volumes ng gas tsaka liquid. So we'll discuss the liquefaction curve and the Maxwell equal area correction later in this physical chemistry course. Okay? So how do you derive the expressions for the critical parameters PC, TC, and V bar C in terms of the van der Waals constants A and B? Okay? So, isulat muna natin yung van der Waals equation of state. P is equal to RT over V bar minus B minus A over V bar squared. So, the first thing to do in my technique, using my technique, is to convert this to cubic equation, PV cube minus RT plus PB B squared plus AV bar minus AB is equal to 0. However, ang gagawin ko, di-divide ko lahat by pressure. So, V cube minus RT plus PB over P B squared plus A over P V bar minus AB over P is equal to 0. Okay? So, maintindihan natin mamaya kung bakit ko yun ginawa. So, punta muna tayo sa critical molar volume. So, syempre, at the critical point, the critical molar volume is equal to the molar volume of your gas. Okay? So, syempre, V minus VC is equal to 0. This is a simple relationship. Pwede nating i-cube, okay? Yung difference na to, you will have V cube minus 3V squared BC plus 3V VC squared minus VC cube is equal to 0. Okay? So, this is an interesting relationship kasi nakikita nyo na yung ginawa ko kanina, ito, okay, so i-move ko lang, ay related dun sa ating na-construct na cubic equation. Okay? So, pwede nating i-relate yung individual variables kasi pareho lang siyang naka-equate sa 0. So, pwede nating i-relate yung variables or yung terms na to, okay? Tsaka yung terms na to. Okay? So, equate natin sila. So, VC cube is equal to AB over P. Tapos, pwede nating i-equate yung 3VC squared is equal to A over P V bar. Okay? So, makakancel yung V. We will have 3VC squared is equal to A over P. Okay? Pwede nating i-rearrange to para makuha yung A is equal to 3PVC squared. So, syempre, we are talking about the critical region. So, ibig sabihin, since this equation holds, ibig sabihin, yung pressure mo is also equal to PC and your temperature is also equal to TC. So, therefore, A is equal to 3PC squared. Okay. Yeah. So ngayon, gamitin natin itong expression na to para makuha naman yung B. Okay? So isa-substitute natin yung A dito sa expression na to. So VC cube is equal to since A is 3 PCVC squared, 3 PCVC squared B over PC. So, syempre PC na yan. Okay? Tsaka PC na rin to. Tsaka ito. So, cancel yung PC. Cancel siya. Cancel yung VC squared. Okay? So, VC is equal to 3B. Okay? Yeah. So, nakuha na natin yung expressions for A and B in terms of the critical parameters. Madali lang siyang makuha. Okay? So now, let's derive another parameter called the critical compression factor. So the critical compression factor is equal to PC VC over R DC. Okay? So, ano kaya yung magiging expression natin for the critical compression factor? So, gamitin natin yung terms na nandito. Gamitin naman natin yung terms. Okay? So, 3 B squared VC is equal to RT plus PCB B over PC B squared. Siyempre, cancel na yung V na hindi critical. Okay? So, makikita natin dito na 3VC is equal to RT plus PCB over PC. Okay? Since 3PCVC is equal to PCB plus RT. Okay? So, minultiply ko na yung PC dun sa taas. So, saan equal yung B? So, B is equal to VC over 3. So, 3 PC VC is equal to PC VC over 3. Okay? Kasi sinubstitute natin siya dito. Plus RT. Okay? So, 3 minus 1/3. Nililipat ko ito sa kabila. PCVC is equal to RT. Okay? So, what is 3 minus 1/3? That is 2 and 2/3. Okay? So, 2 and 2/3 or 8 over 3. So, i-convert ko na lang siya sa proper fraction. 8 over 3. Okay? PCVC plus RT. Ngayon, divide natin both sides by PCVC. 8 over 3 is equal to RT over PCVC. Therefore, yung inyong critical compression factor, which is equal to PCVC over RTC. Okay, kalimutan ko yung mga C sa temperature. Okay, lagay natin siya lahat. Okay, is equal to 3 over 8. So, meron tayong value ng ating critical compression factor. So, this is interesting kasi it states that the critical compression factor of Van der Waals gas or any Van der Waals equation of state or any gases that follows this particular equation of state, kapag nasa critical region na siya, ang kanyang critical compression factor or ang Z ng gas na yon is always 3.8 regardless of the gas. Okay? So, sample problem. Okay? So, calculate the molar volume of neon, a Van der Waals gas at 0.85 atm and 298.15 Kelvin. So, given na yung mga critical parameters, VC 0.042, PC is 27.24, and TC is 44.4 Kelvin. So, A is equal to 3PCVC squared. Substitute nyo lang yung values. Makukuha nyo yung 0.1441 atm liter squared per mole squared. Okay? So, for V, B, divide nyo lang yung molar volume, critical molar volume sa 3, 0.042 liters per mole divided by 3 is 0.014 liters per mole. So, after nun, makukuha mo na yung A and B. So, pag may A and B ka na, you just have to solve for the real volume or the real molar volume using this expression, PV cubed minus quantity RT plus PV, quantity V squared plus AV bar minus AB is equal to 0. Solving for V real using your calculator, makukuha mo yung 28.79 liters per mole. Okay? So, that's how you perform calculations for the critical parameters or using the critical parameters. So, yung critical parameters na yan, magagamit nyo para ma-solve nyo yung gas constants. Okay? Kapag iba yung equation of state, again, iba rin yung makukuha yung expressions for the critical constants. Okay? So, yung A and B, for example, ng Berthelot equation or ng Redlich equation, syempre, iba yung magiging expression niya compared sa van der Waals equation of state. Okay? So, see you next video.